So when we look at this equation, we are going to be taking and trying to figure out what is going to be squared. Is it going to be in the format of x minus h squared equals 4p y, or is it going to be y minus k, or is it going to be y minus k squared equals 4p x minus h? And so you look down here and you see that it's x squared, so that means we are stuck with the top one. So now we look to see, what can I do to get it to where it's just x squared? Well, if I divide everything there is divisible by 4, so I'm going to start with dividing everything by 4. And that gives me x squared minus 10x plus 12y plus 1 equals 0. And so now my goal is to get it to where anything dealing with x stays on the left hand side. Everything else moves. So I'm minusing the 12y and minusing 1. Which gives us x squared minus 10x is equal to negative 12y minus 1. Now my goal is to get it to where I have it in that squared format. So that means I need to complete the square. So I need to figure out what do I need to add to both sides in order to do that. So I take the 10, divide it by 2, and I square it. That gives me 10 divided by 2, which is 5. 5 squared is 25, and that's what I add to both sides. Now, I come down and I write the x, the middle sign, and whatever that number is that I squared. And then I square that term. On the other side, I just go ahead and bring down and do the math. So now on the right-hand side, I need to factor that out. I need to have it to where it's just a y as the first thing in the parenthesis. So whatever's in front of my y has to be divided out of both of them. So negative 12, we divide it from negative 12y and we come up with just y. Divide it from 24 and we get negative 2. So now we try to find all our pieces. So my first thing I look for is where the vertex is. My vertex is at negative 5. Is inside here, so that means my vertex is going to have a positive 5 for the x. And there's a negative 2 inside here, so that means it's going to be a positive 2 for my y. That's weird. Positive 2. So 5, 2 is that ordered pair for my vertex. And since it's x squared, that means that we're going to have either an up or a down parabola. We need to find our p-value in order to figure out what it is. And so remember, 4p is equal to whatever is in front of that parenthesis on our linear side. So negative 12. So divide both sides by 4. P is equal to negative 3. And so down is the direction if it's negative. So I go down 3. And that gives me my focus. Which is still at that 5, I went down 3, so it's now at -1. My directrix is going to go the opposite direction. So if I went down, I'm now going to go up 3. And it's going to be a line left and right at that spot. Next thing I need to do is write the equation of that. So it went left and right, so that's going to be y equals, and we went up 3, so that's going to be y equals 5 is my directrix. Now to find my axis of symmetry. My axis of symmetry is going to go through my focus and my vertex and is perpendicular from my directrix. And so that's going to be x equals, in this case, 5, because that's the value of the x value. Now we need to draw in my parabola. And my parabola is going to curve around the focus. And so there will be my parabola. So let's go ahead and go on to the next one. This time we're going to be writing the equation standard form for each parabola. So we need to determine, is it going to be an x squared or a y squared that we're going to start with. And so we need to graph the details to help us figure out which way we're going to be opening, if it's up and down or left and right. And so we want to the vertex of 3, 2 is my vertex. And my focus was at 3, 4 is my focus. So I know my parabola has to go this direction. The distance between my focus and my vertex is +2 because I'm opening up. And so that gives me all the information I need to start. So that tells me that P is equal to 2 is opening up and down. So that tells me that it's x squared. The other piece I'm going to need is my vertex, which tells me my h and my k. So x minus h, so 3 squared, is equal to 4, and this value is where you put your p value, so 2 times y minus 2. And so we simplify that further by multiplying the 4 and the p, which gives us 8y minus 2. And the other things that we need to label is we need to come back in here and label where my directrix is, which is at y equals 0, where my axis of symmetry is, which is at x equals 3. Next one, we're going to start the same way. We go ahead and plot the information we have. 4, 1. And this time it tells me where my directrix is. The directrix is at x equals 2. So that's an up and down line where it's equal to 2. So my distance from my vertex to my directrix is -2. So my distance to my foci is +2. So that tells me my P is 2. My parabola is opening left to right, so that tells me it is a y squared parabola. And so remember, this is HK. Remember though that everywhere that there's a y, we're going to use the y value, so that's going to be the 1. Goes in opposite, so it was positive 1, so it's a negative 1. The p was 2, so I'll multiply by 2. And then the x value was 4, so minus 4. And so simplifying it down, y minus 1 squared is equal to 8x minus 4. Labeling the things that we need to label. The only thing left we need to label is we need to label where our axis of symmetry is, which is y equals 1. And my focus, I didn't give the order pair of the focus, which was at 6, 1. So that's that, and then we graphed and labeled the parabola. So now let's kind of talk about the overview. So the graph is opening up and down. That's when we had it was squared. The orientation of the parabola is vertical. The axis of symmetry is that line that we can fold it across. So that's going to be this line here, which goes up and down. So that means it's x equals, well, the x value is that h. So x equals h. Our vertex was h comma k. And the coordinate of my focus was p units up from, and so if we're going up, that means we're going to change the y value. So h stays the same. We do k plus p. Now directrix is a line, and it's going to be a y equals line. And so we're going to do our y value again, so k, but this time we're going to subtract p because it always goes the opposite direction. And these were either concave up or down. So let's take the other side. Let's look at it from the other perspective when it's a horizontal. Then our axis of symmetry is going to be y equals the y value of our vertex, which is k. Our coordinate of our vertex is still the same thing, h comma k. But this time we're making and moving the x value, so it'll be h plus p, k. And then the directrix is going to be x equals, again we're dealing with h, so we're dealing with the x value, minus p. And these are the ones that open right, left. So we talked about that these are all so that we can go into other details, whether it's writing the equation with the parabola is. We're going to be going into, if you go into calculus, you'll start looking at the area under the curve, and it starts getting you into volumes of spheres. But we're going to take this first one, and the first question asks us, we have this suspension bridge where we have a cable suspended between 2 points. It touches the bridge here, and so we want to know the equation that can represent this parabola. But it doesn't tell me where my origin point is. And if that's ever the case, always put your axes to where your origin point puts the vertex at 0, 0, because that's an easier equation to work with. Since this parabola is going up and down, we're going to want to choose to use the x squared equals 4py equation. And since our vertex is at 0, 0, we can go straight in here. But we don't have a number to plug in for y. So we need to figure out what that y value is, or that p value is. And the only way to do that is if we actually plug in values for x and y. So let's do that over on the side. And so we need to find out an ordered pair. Let's take this point here, the top of that bridge. We know that the bridge all the way across from post to post is 900, so that would make this 450. So that would make this ordered pair 450, comma, 75. And so we're going to take these pieces of information and we're going to calculate each of the things that we need. And so we're going to do 450 squared is equal to 4p times 75. So 450 squared gives us 202,500. And then 4 times 75 gives us 300p. So when I divide both sides by that 300, it gives us p is equal to 675. And so that means I need to take and put up here 675. Well, that's not the best way to write it. So let's go ahead and multiply that out. So 4 times 675 gives us, oh, just a second, I zoomed out somehow. $2,700 y. So that would be the equation. And so something like that could be gone into calculus where we can use other things and discover more information. So now let's take a satellite dish. One of the big things on your satellite dish is your receiver needs to be at the focus point. So when we're designing that parabola dish, we need to know what this distance is from this vertex to that focus point. So it tells me the satellite dish is 5 feet wide. And it's 1 foot deep. So that puts this ordered pair at 2.5, comma, 1. And so we're going to do the same thing. So since this is up and down parabola, we're going to do x squared is equal to 4py. This time we know our x is 2.5 squared is equal to 4 times my p value times my y value, which is 1. 2.5 is 6.25, or 2.5 squared is 6.25, and this becomes 4p. So when we take 6.25 and we divide it by 4, we get that it is 1.5625p, which is 1 9/16. So we need to be above the receiver by 9/16, or the receiver will be above the dish by 1 9/16 up. So 1 9/16 feet from the vertex. And so let's do the last problem. And so the other thing that we talked about that we use this a lot in is when we're studying mirrors or lenses. And so when you're standing and you're looking in front of a concave mirror like this, your image is reversed. And if you stand back at the focal point here, then your image is not only right side up, is actually going to be the same size as what you are. It's not going to be distorted in any way. So if we know that this mirror is 72 inches tall, that makes this point up here to where it is 6,36 because it would be half of that 72 height. So this time we're opening left to right, so we do y squared is equal to 4px. And again, it's wanting us to find out the length, the distance we need to stay away from in order for it to be at the focal length of the mirror. And so we're going to take that ordered pair and we're going to plug it in. So 36 squared is equal to 4 times p times 6. So when I do 36 squared, I get 1296 is equal to 24p. And so I want to divide that by 24 on both sides. And we get that p is equal to 54 inches. Well, we're not going to measure that in inches. So let's go ahead and think about that in measurement of feet. We need to be 4.5 feet away from the mirror in order for it to be at the focal point.